So carrying on from the last lesson, I just remembered now, I've not probably said the most obvious part of why it's called the CAS diagram. Well, basically, there's no real reason why it's called the CAS diagram, apart from it's an acronym that spells out CAS. So this one goes, C-A-S-T. Now, other people, call other things like all students try coffee. Whatever you want to use to remember, I've always just called it the CAS diagram. It starts here, you work your way around. Some people have complained, they put the C there, but just try your best to remember it the best way you can. But anyway, so why is it useful again? So it tells you about the angles. You can figure out the values for angles that aren't in the first quadrant. So let's just take an example here, okay? If I say, okay, well, it's 30 degrees, which we know sine 30 here is going to give you 0.5, okay? That's great, 30 degrees. But what we also see is that if we keep going on, we'll get the same value here in the second quadrant, right? So we get the same value here, 150 degrees. So, you could say, sine 30 is equal to sine 150 is equal to 0.5. Okay, so what do we know about this 150 degrees? Well, 150 degrees is going to be right in here. 50 degrees. Well, I'm going to actually draw this up another way. So that's 150 degrees there, 150. So what is the angle? So this is what we're really leading on to. Okay, so this is 150 degrees. I wonder what the angle between here and the horizontal line is. It is 30 degrees. Oh, hang on a sec. Maybe there's a connection here. So so you can see here, 30 degrees was also the angle that gave you the value you wanted. And now I'm saying the difference between the horizontal and the angle I have is also giving me the value I wanted here. So maybe there's a relation. Well, there is basically. This is called the related angle, or the related acute angle. And basically, what is that? Well, an acute angle is an angle that's less than 90 degrees. And it's between the terminal arm of the x-axis in quadrants 2, 3, and 4. So it's a bit of a mouthful, but what does this mean? Well, basically, you get a related acute angle in these quadrants here. So basically, it's the angle between this arm and the horizontal line, okay? So let's go through these examples and I'll show you what I mean. So here, in the first quadrant, there's going to be no acute angle, because we said here there's no related acute angle, so NA. But in here, we can see that this is 120 degrees to here. Okay? So in here, to get to here, which we know 180 degrees in a straight line, this must be 60 degrees. What about here? Well, we can see that this is 225 degrees. This goes all the way around here, 225, 225. But what about the acute angle? Well, we're going to be working the other way now. We're going to be working from here to here, right? So that's going to be, well, this is 180. It's going to be 45 degrees. And what about over here? 320 degrees. So again, it always goes positive, round from 0. So this is 320 degrees. And this in here will be, choose a different color, will be what? So 20, I want to get back to 360. So, and this also loops round. Yeah, that's the thing to remember. So it's 0 and 360. So it's 0 when it starts, and by the time it finishes, it's gone round 360. This will be 6. This will be 40 degrees. Okay, so that's the idea behind the related acute angle. So how is this useful? Well, we can actually get a formula, so we can always figure out the principal angle or the angle that we're looking for, the one that we're interested in. So I'll do a quick example here, then I'll move on. So just say, okay, we've got 120 degrees. Just say I wanted to know what the sine of that value is. Okay, so what's sine 120? Right, in here, that's going to be somewhere in here, 120. So it's in the second quadrant, and it's sine, so it's going to be positive. So I know the acute angle is 60. So what I'm really saying is sine 120 is equal to positive sine 60, which we know is positive root 3 over 2. We're just confirm that for a triangle. You think about it. Root 3, 2, 1, 60 degrees down here, opposite over hypotenuse. Very good. But what if I asked what cos 120 degrees was? Okay, cos 120. Doing a different color here. So if I was after cos 120, how do I figure this out? Okay, well I can still take 120 degrees, and I know that there's going to be an acute angle of 60 degrees. But what I can see here is that for the cos diagram, let's go sketchy here, just like that. Okay, and that happens at 90. I see for 120, it's going to be negative, right? It's going to be some negative value. So what I need to do is I need to figure out, I need to say that like this is going to be equal to cos negative cos 60. So what's that going to be? Cos of 60 is going to be 1 over 2. So this is negative 1 over 2, right? Okay, we'll go on and do some more examples and I'll show you the formula, but that's the general idea.